solving addition/subtraction equations. For example, if we said to you, let me write this, the sum of y and 3 is equal to 12. Solve for y. Well, let's look at that. Let's dissect that statement I wrote there. The word sum. Sum means what? Addition. Y and 3 is equal. That's the same as saying equals to what? 12. And this is actually an easy one. It doesn't even require methods to solve it. But as the problem gets really ugly, I'm going to give you some techniques now to help you solve these problems. Ideally, your goal is, that's your goal, is you want all the x's on one side and you want all the numbers on the opposite side. That's what your goal is. And here we have y plus 3. The 3 is on the wrong side. Since you have a plus 3 on this side, you need to subtract 3 from this side, and you subtract 3 from that side. Whatever you do to one side, you're going to do the same thing to the other side. What will happen if you subtract 3? What's 3 minus 3? These are gone. And you end up with what? Y equals 12 minus 3, which is 9. So that's how we're going to solve them. I'm just going to put the equation, try to solve them. Instead of giving you a story, solve. Y plus 9 equals 17. So what are we going to do? Subtract 9. These cancel each other out. And we have what? Y equals 17, take away 9. 8. Let's have fun with it. N minus 2.5 equals 0.7. That's a minus 2.5. When we had addition, what was the opposite to addition? We subtracted 3. We had plus 9, the opposite to addition, subtraction. Here we have subtractions. So guess what the opposite to subtractions? We add. We need to make sure these numbers are opposite. Let's add 2.5 to both sides. Minus 2.5 plus 2.5, gone. And we have n equals, let's add them. 5 and 7, 12, 2 carry 1, 3.2. T minus 0.9 equals 1.8. That's subtraction. What's the opposite of subtraction? Addition. Nope. T equals, let's add them. There's a decimal point, 0.98. Is that 2.7? Let's make them a little bit uglier. Let's take you back to chapter 2, everyone's favorite chapter. Not really. X plus 1/3 equals 3 1/2. Again, we have addition. What's the opposite to addition? Subtraction. So these two will cancel each other out. So my answer is going to be x equals what? 3 1/2 minus 1/3. And if I know how to subtract them, I'm in good shape. Where did we cover this? Chapter 2. When you have mixed numbers, we said probably the easiest thing, change them what? To improper fraction. So review for the test almost. 2 times 3. 6 and 1. 7/2 minus 1/3. If you're going to add or subtract numbers, what do you need? Which is in this case what? 6. Very good. That means I will have to multiply the 2 by what to make it 6? 3. 7 times 3, that's 21. I have to multiply the 3 by 2 to make it 6. What's 21 minus 2? 19/6. Now we probably have to change that to a mixed number. So what is 19 divided by 6? That's 3. 3 times 6 is 18. What's the remainder? 1, 3, and 1/6. So getting the equation like ready is not bad. It says x equals this minus that. The question is, how do we subtract these? If you remember your chapter 2, you're in good shape. If you struggle there, you're going to struggle with this one too. Let's try another one. M minus 1/4 equals 5 1/2. Let's look and see. What are we going to do here? That's minus 1/4. What do we do? Add 1/4. Gone. M equals 5 1/2 plus 1/4. Change them to improper fraction. 2 times 5, 10 and 1. Again, we're subtracting. So the least common denominator for us is what? 4. Very good. It is 11. Yep, thank you. My mind's somewhere else. I'm trying to think of the next example already. Plus the 1, I forgot the 1. So I need to multiply this by what to make it 4? 2 times 11, 22 minus 1, what do we have? 21 over 4. Now again, go to the side. 21 by 4, it looks like a 5. 5 times 4 is 20. What's the remainder? 1. That's 5 and 1/4.
Wouldn't you be adding 22 over 4?
Minus. Oh, I don't know why I put I don't know why I put actually minus here. That should have been what? Plus. Told you I'm falling asleep here. 23 5 3/4. In the back of my mind, I'm trying to give you an example where we might use that in real life. I'm going to give you, well, let's see. I'll give you one. So nowhere? Let's try this example. John. Let's pick a name here. John. Let's talk about John. After buying, John wants to buy something. Let's get him buy something. What is he going to buy? An Xbox. How is that? Is still the newer one? Is still 360? Is that the newest one?
Xbox One.
Xbox One. What happened to 360?
Old.
That's old? My kids were young. That's what they had. So the one is newer than 360? Okay. Xbox One, is it called One Elite or just one? Just one? Okay. What's the price of it?
$400.
400? So 3, let's change it. 379.96. That's what he spent on it. After buying that, he has $46.22 left. How much money did he have before? I want to make an equation out of it.
X minus 379.96 equals 46.2.
I like that. What'd you say? So since we're not sure how much money John has, let's call that X. X, the amount of money John has. Take away from it the Xbox, which is what? 379.96. When you subtract the result, it says equal to, is that what you said? To 46.22. So that's a minus. So what's the opposite to subtractions? We add 379.96. Let's add them. 6 and 2, 8. 9 and 2, 11. 1 carry 1. This will be 16. 6 carry 1. $426.18 initially he had. Now, right now, this problem is just add the two numbers. Why even you wasting your time with the equation? But as the problem gets bigger, we're trying to give you techniques. I will start dealing with bigger problems. You have a set of rules. When you have subtractions, you add. When you have addition, you subtract. Because the problem is not going to stay that simple. Okay.